Hello everybody, welcome to the week 5 of our tutorials. Hope you've been enjoying the tutorial so far. We are going to discuss all the questions in this video, but we are going to discuss them even further in our actual tutorial sessions. So the first question is, electricity is a good with a few or no close substitutes. What would you expect about the price elasticity of demand for electricity? So if it's a good with few or no substitutes, even if the price increases, the quantity demanded for that good shouldn't change too much. So we are expecting the elasticity to be relatively inelastic. So the correct answer here is B, relatively inelastic. Question number 2, imagine the percentage change in the supply of good is equal to 50% and the percentage change in price is equal to 25%. The price elasticity of demand is equal to, and we have to calculate it, and we also have to determine whether it's elastic or inelastic. So on our board, we have the formula for price elasticity of supply, which is exactly the same as the formula for price elasticity of demand. So it's percentage change in the quantity over the percentage change in price. Just in this case, we have quantity supplied instead of quantity demanded. We are told that the change in supply of good is equal to 50%. So our change in quantity supplied is 50%. And we are also told that the percentage change in price is equal to 25%. So our change in percentage change in price is 25%, which gives us the price elasticity of supply, which is equal to 2. Since we know, and we have in our formula sheets all the table explaining whether something is elastic or whether the price elasticities are elastic or inelastic, we know that everything above 1 actually means that the price elasticity of supply is elastic. So the correct answer to this question is B, 2, and relatively elastic. Question number 3, we can expect the cross price elasticity of demand between tea and coffee to be, and then we have to determine whether it's positive or negative and whether those are inferior, substitute, or normal goods. In your lectures, you already discussed it. So tea and coffee would be substitute goods. And you also, in your lectures, you were told that cross-price elasticity of demand for all substitute goods should be positive. Hence, the correct answer is D, positive, indicating substitute goods. Question number 4, assume the demand for water is perfectly inelastic. If a firm raises price for water by 8%, what could be subsequent change in its revenue? So if demand for good is perfectly inelastic, it means that price elasticity of demand is equal to 0. And when elasticity of demand is equal to 0, when price changes, quantity demanded remains the same. What happens to the revenues? We know the formula for total revenues would be price times quantity, and we know that our quantity stayed exactly the same because our demand is perfectly inelastic. However, we know that our price increased by 8%. So this is the same, this increased by 8%, and hence the revenue should be increased by the same amount as price because the quantity stayed the same. Hence, the correct answer to the question number 4 is D, 8%. Question number 5, assume a cell phone costs $50. When the price increases to $75, demand falls from 5,000 to 3,000. Use the midpoint method to find the price elasticity of demand. Note, in economics, elasticity is generally reported as a positive number. So on the board, we have the formula for midpoint price elasticity of demand, and it's Q2, so quantity number 2 minus quantity number 1 divided by quantity in the period 2 over plus quantity in the period 1 all over 2. And then we have the same for price, so price 2 minus price 1 over price 2 plus price 1 over 2. So if we go on and calculate our price elasticity of demand using this formula, we are told that demand falls from 5,000 to 3,000. So quantity 1 is 5,000. So quantity 1 is 5,000 and quantity 2 is 3,000. So we have 3,000 minus 5,000 over 3,000 plus 5,000, all divided by 2. And then all of that is divided by changes in price. We have that initial price was $50 and then it increased to $75. So we have 75 minus 50 over 75 plus 50 divided by 2. So 3,000 minus 5,000 is minus 2,000. And then we have 3,000 plus 5,000, which is 8,000 divided by 2. And then we have 75 minus 50, which is 25, divided by 75 plus 50, which is 125 divided by 2. And then we can further make this nicer. So minus 2,000 over 4,000 divided by 25 over, so we have 62.5. And then finally, this should give us minus 2,000 times 62.5, and then 4,000 times 25, so we have minus 2,000 times 62.5 divided by 4,000 times 25, which is equal to minus 125,000 divided by 100,000, which is equal to minus 1.25. And we are told that in economics, we usually report elasticities as a positive number, so we should just disregard this minus in front. So the correct answer would be B, 1.25. Next, we have question number 6, which states, assume that a football club has the following demand curve for the season tickets. And then we are supposed to calculate different quantities and sketch the graphs as well. So let me clear up the space. So we have somewhere to write. So the given demand curve for this football club is quantity demanded is equal to 50,000 minus 50p. And question number A, what quantity of season tickets is demanded when the season tickets are free, so price is 0. So we have price is 0, and we should plug this price into our initial equation to obtain the quantity demanded that is required from us. So it's 50,000 minus 50 times 0. This is obviously equal to 0, and then we have that the quantity demanded when the price 0 is 50,000. B, at what price do season tickets cease to be bought? So in this case, our quantity is 0, and we should determine our price. So we again use our first equation to determine this. So we have 0 is equal to 50,000 minus 50p, and we have 50p is equal to 50,000, and our p is equal to 8,000. Yeah. Under question number C asks us, so using information from A and B, sketch the demand curve for this club. So we have quantity on our x-axis, we have price on our y-axis. We know that if price is 0, the quantity demanded is 50,000. So we have quantity of 50,000 and price 0. And if quantity is 0, we know that the price is 1,000. So we have price of 1,000 here and quantity 0. So our demand curve is downward sloping, connecting these two dots. Then we have question number D. What amount of season's ticket is demanded at £600 and at £700? And what revenue is generated from the season's tickets at each price? So we need, again, additional space to do this. Okay. So we have our quantity demanded formula that was given to us at the very beginning of this task, which was 50,000 minus 50p. And we are going to use this formula to determine our quantities demanded at £600 and £700. So in the case number 1, our price is £600, and we are just going to plug it in this formula to determine the quantity demanded for this price. So we have 50,000 minus 50 times 600, which is equal to 2. So we have 50,000 minus 30,000, and this is equal to 20,000. So when the price is £600, the quantity demanded of tickets is 20,000 tickets. When the price is £700, quantity demanded is 50,000 minus 50 times 700, which is equal to 50,000 minus 35,000, which is equal to 15,000. So when the price is £700, the quantity demanded is 15,000 tickets. And revenues in each case, so we know that revenue is quantity times price. So in the first case, our price is 600 and our quantity demanded is 20,000, so it's 600 times 20,000. So revenue in the first case is 12 million. And in the second case, again, revenue is quantity times price. So it's 700, because our price in the second case is 700 and our quantity is 15,000. So the revenue is 10,500,000. Yeah. So we just solved the question under D. E asks us, using the average midpoint formula, estimate the price elasticity between 600 pounds and 700 pounds. So we are again going to need more space. So midpoint formula is the same formula we used earlier in one of the questions before. So price elasticity of demand using the midpoint formula is equal to Q2 minus Q1 over Q2 plus Q1 over 2, and then divided by P2 minus P1 over P2 plus P1 over 2. So we calculated our quantities. So in the task under D, and we should determine here what happens to so the price elasticity of demand between 600 and 700 pounds. So 700 pounds would be the new price and 600 pounds would be the old price. So at 700 pounds, 15,000 tickets are sold. So we have 15,000 minus 20,000, which is the quantity when when the price is 600 pounds, over 15,000 plus 20,000 over 2. And our new price is 700 pounds. Our old price was 600 pounds. And then we have 700 plus 600 over 2. So we have minus 5,000 divided by 35,000 over 2, all divided by 100 over 1,300 divided by 2. So we have minus 5,000 over 17,500 divided by 100, and then we have 650. So we have minus 3,250,000 divided by 1,750,000, which gives us the price elasticity of demand of minus 1.86. And question under F asks us, what can we say about the price elasticity of demand between points on the demand curve corresponding to the season ticket prices of 600 and 700 pounds. So we got the elasticity of 1.86, which shows us that this is the price elastic region of the demand curve as the elasticity is greater than 1. Under G, we have between what price range does raising season tickets increase revenues from season ticket sales. So raising prices will increase revenues if it occurs in inelastic part of the curve. So in the other part of the curve from this one, where the distinguishing point would be 500 pounds. So if we recall our demand curve from the very beginning, we had that it was, the quantity was 50,000 when the price was 0, and we have the price was 1,000 when the quantity was 0. So this region of the demand curve would be the one we had here, so the elastic region, and this region would be inelastic one. So up to £500, if we increase the prices, the revenues will increase. But we are going to discuss this task even further at our tutorial sessions. So hope you enjoyed this recording, and see you in class next week.